Glass is not a liquid. Side by side, an old window ripples with uneven thickness and waves, its bottom edge noticeably heavier. In contrast, a modern pane gleams, flawless and uniform from corner to corner. This difference has fueled the myth that glass slowly flows downward over centuries, pooling at the base like a sluggish liquid. The truth is more intriguing. Scientifically, glass is an amorphous solid. During rapid cooling, molten silica traps its atoms in a disordered pattern. Unlike crystalline solids, which arrange their atoms in neat, repeating lattices, glass's atoms are frozen in place, random, yet rigid. While its atomic structure resembles a liquid's lack of long-range order, glass behaves like a solid, with no measurable flow at room temperature, even over thousands of years. The variable thickness in antique windows arises from history, not physics. Centuries ago, glassmakers shaped molten glass by blowing, casting, and flattening it by hand. These methods produce sheets with unpredictable thickness. Glaziers typically install the thickest edge at the bottom for stability. Today, the float glass process spreads molten glass on liquid tin, creating panels with perfectly even surfaces. Scientific measurements confirm glass does not flow. Its solid, amorphous nature is constant. Old stories fade with evidence, myths fade, physics remains.